Section 3.223-T. The following data represent the weights in grams of a random sample of 50 candies. In Part A, we want to determine the sample standard deviation weight. Now, since we have 50 data values, we're not going to do like what we did at the previous part of our exercises. We had a small data set, so we're able to do that by hand. Now we want to be able to take use of, or make use of technology. So again, the sample standard deviation S is obtained by taking the square root of the sample variance. To find the sample variance, we're going to use technology, and this value is rounded to 2 decimal places. Or we could just find the sample standard deviation. So I'm going to open up this data set into StatCrunch. Okay, so what we're going to do is we're going to be able to find the sample standard deviation. So we're going to select Stat, and then go to Summary Stat, and then select Columns. And we're going to select Variable 1, and then we're going to go ahead and go to Standard Deviation. And then select Compute. And then we're going to copy that. And then we can see that we have rounded to 2 decimal places. It's 0.07, which is what we get over here. So you can see here that our sample standard deviation rounded to 2 decimal places because of the 8 gives you 0.07. Now in Part B, it says on the basis of the histogram on the right or here below, comment on the appropriateness of using the empirical rule to make any general statements about the weights of the candies. So when you look at this particular histogram, what we want to determine is, okay, does it form a bell-shaped situation? Well, if we draw a bell shape around the histogram, you can see that it does form a symmetrical bell shape. So the histogram is bell-shaped, so we can use the empirical rule. Now, since we want to use the empirical rule, we determine what the sample standard deviation is, but we also need to figure out what is the mean of our data. So if we go back to our StatCrunch and go to Stat, Summary Stats, and then select Columns. And again, we're going to select our column, and we want to be able to find the mean, and then we're just going to select the standard deviation again anyway, just because we've already done that. And then we're going to select Compute. Okay, so let's go ahead and we're going to copy that data from here. Okay, so again, what StatCrunch is doing is it's allowing us to then find out what the mean is for a large set of data a lot quicker than for us to be able to do this by hand. So since we know the mean is 0.84 and the standard deviation is 0.07, we're going to use the empirical rule. So the mean down here, if you notice, is 0.84. Okay, and then what do we need to do? Well, we need to figure out what is it, 1 standard deviation from the mean, 2 standard deviations away from the mean, and 3 standard deviations away from the mean. So if we add 0.07, well, that's going to give us the 1 standard deviation away from the mean. If we add another 0.07, then we get our 2 standard deviations away from the mean. And then if we add another 0.7, we get our 3 standard deviations away from the mean. Likewise, we can see that the difference between here, if we subtract 0.07, then we get 0.77. Subtract again 0.07, we get 0.70, and then subtract 0.07 and we get 0.63. So what we've done now is we've determined, okay, this is the mean. We can see that 0.77 and 0.91 represent 1 standard above and below, standard deviation above and below the mean, which is the 68%. If we go 2 standard deviations, we add another 13.5 on both sides. If we go 3 standard deviations, we're adding another 2.35%. Again, going back to the definition of the empirical rule. So now, using the empirical rule to determine the percentage of candies with weights again between 0.7 and 0.98 grams, we know that the mean again is 0.84. So we want to be able to use the empirical rule to determine the percentage of candies with weights between 0.7 and 0.98. So let's go ahead and find this information. So between 0.7. So here we have 0.7. So we're starting at 0.7, and then we're going all the way to 0.98. So that means everything in between this. So we have 13.5, 34, 34, and 13.5. Well, let's go ahead and add those percentages up. So if we take 13.5% plus 34% plus 34% plus 13.5%, then that's going to give us a total of 95%, which is what our answer is for the percentage of candies with weights between 0.7 and 0.98 grams. Now for part D, it says determine the actual percentage of candies that weigh between 0.7 and 0.98 grams inclusive. Now, to calculate this percentage, what they want us to do is to count all the candies that weigh between 0.7 and 0.98 grams inclusive and divide this number by 50. So let's take a look at this. If we count all the numbers, so there's only one number, let's see here, this number, these, all of these. So we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, and 49. So there's only one value that's above the 0.98, and everything else is in between 0.7 and 0.98 inclusive, meaning that it's got to include 0.7 and 0.98. So if you take a look here, we take 49 and we divide it by 50. When we divide it by 50, we get a decimal of 0.98. Now to convert this to a percentage, we multiply it by 100%, and that gives us 98%. Now, in part E, we want to use the empirical rule to determine the percentage of candies with weights that are more than 0.91 grams. So here is 0.91, and it's everything that's more than that. So when we want to calculate the percentages, so we can see that we have 13.5%, and then we have 2.35%, and then we also have this 0.15%. When we add that together, that gives us a total of 16%. So using the empirical rule tells us that the percentage of candies with weights more than 0.91 grams are 16%. Okay, now in part F, what they want us to do is they want us to determine the actual percentage of candies that weigh more than 0.91 grams. So to calculate this percentage, we're going to count all the candies that weigh more than 0.91 grams. And then we're going to divide this number by 50. So the table over here, okay, is going to shade all the candies that weigh more than 0.91 grams. So we have 1, 2, 3, 4, 5, 6, 7, 8. Now, keep in mind here, it doesn't say inclusive. Now, inclusive means that in part D, we had to include 0.7 and 0.98. Now, since it doesn't say inclusive, we're not going to include the value of 0.91. So the only numbers that we have that are above 0.91 is 8. And we're going to divide that by 50, which gives us a decimal of 0.16, multiplying that by 100% gives us 16%.